This is a video of the project for PepsiCo. As you can see, here is the I/O table. This project was created using the Arduino microcontroller. So we have a push button for start, a push button for an e-stop, 4 lights that are showing that the blower molders are on or off. We have another LED that's signifying that plant air is on, meaning that we have extra air coming from the high pressure system. We have 2 servo motors acting as the high pressure compressors, and we have 4 potentiometers that are acting as selectors to say that the blower motor is required for the line to run. So the description is, when push button 1, which is the start, is selected to the on position, air compressor 1 will run at 0%, 70%, or 100% depending on the load required by the blower molders. As required, air compressor 2 will run at 0, 50, or 100. Any extra air will be sent to the low pressure plant air system or released to atmosphere. All systems will shut down when PB2, the e-stop, is pressed. So let's have a look at how those systems run in a little bit more detail. Here is a truth table, and the truth table is showing when each blower molder is on, what is the CFM, or what is the air that is required. So you can see from the truth table we've got all the scenarios of the blower motor requirements and the CFM that's required from that. At the bottom you can see where those numbers come from. If blower molder 1 is on, add 700 to the required CFM. Same with blower molder 2. If blower molder 3, then add 800. And lastly, if blower molder 4 is on, then add 1200 to the amount of CFM. So that's where that math is coming from there. Scrolling down to the next table, we can see this is the amount of CFM that is created, not that is needed, but is created from the blower molder requirement. So this is taken directly from the amount of CFM that can be produced by the air compressors. So that chart on the far left hand side, or the numbers on the far left side, that corresponds to the chart you saw before. And then across the top we have depending on how fast the blower the air compressors are running. At the far side, that is the amount of CFM produced, and anytime there is an overflow, that air is being sent to the plant. This is what we were trying to reduce, the amount of air that is being sent to the plant, because it's wasted air. As you can see, we have quite a few scenarios where there is no overflow, and that's ideal. We have a couple of scenarios where the overflow is quite high. And then at the bottom, there's a chart there that shows you when each air compressor is running at a certain speed, that is the amount of CFM, or the amount of air that is produced by that air compressor. Okay, so now going over to the model. This is the model that was built to represent the plant. We have here at the bottom, we've got the 4 systems of blower molder systems. Each of the blower molder systems has a potentiometer, which will select the air or the type of bottle that's created. Now that does not change the amount of air that's required in this program, but that is something that could be added later if they found that the requirements did change significantly from bottle to bottle. And then the LEDs are showing when the system is on. So if the LED is off, that means that the blower molder does not require any air. As soon as you see the LED come on, you know that air is required for that system. Over here, we have an LED, and this is signifying plant air. So we do not want to see that light come on. If it's off and the blower molders are running, that's an ideal situation. As soon as that light is on, it means we are producing excessive air. Over here, we've got the 2 servo motors. One of the servo motors is motor 1 for the high pressure compressor, and the other one is motor 2. And to show a drastic change in the amount of air being produced, these servos have been programmed to be either idle at 0%, or they will run in one direction for, in this case, this one will be at 70%. In this case, this one will be at 50%, because that is the actual reality of the motors on site at the plant. And then both of the motors will switch direction when each of them respectively is running at 100%. So over here we have, see that properly, there's our start and our stop switch. There's the plant start and the e-stop, which we have in case we're getting electrocuted by this high power system. And here it's a little bit hard to see because I have a roof on to try and protect and cover all these wires, but we've got the Arduino on the left, and that's where all the I/O is wired to. That's our controller, our brains of the system. And on the right we have the breadboard, which is used to do all of the wiring. And the wiring, you can't really see it on top of the board because if you go underneath, you can see all the wiring's been brought down to the bottom just to keep it clean and try and stop those wires from getting accidentally pulled out. So that's the entire system. Let's turn it on so we can see what happens in the plant. So turn that push button on. You can see nothing is happening, but that's because we don't have any requirements for the blower molder. So if we pass back over to the blower molders, we'll select blower molder number 1 and we'll turn it on. So now the blower molder is requiring air. You can see from the light of the plant air that we are creating excessive air, and we have air being produced at the air compressor. Now if we switch number 2 on, so now number 2 is on, we still are within the 70% of air compressor number 1. If we turn on number 3, now all of a sudden we're requiring that extra blower molder. And then if we turn on the last one, did you hear that? That was all of a sudden the second blower molder changing direction because we now require that 100%. So if we turn off one of the blower molders, if it's no longer required, you'll see it turns off. We're still producing plant air. We just switched directions on the blower molder number 2, or the high pressure compressor number 2, because we don't have as much air required anymore. Let's turn it off another one. There we go. So we turned off that second compressor altogether. It's no longer required because we're able to get enough air coming from air compressor number 1. So that's an overview of the system. Oh, let me just show you one last thing. So if all of a sudden, oh no, somebody is being electrocuted, we could press the air stop. So we still have the air requirements. I haven't changed it, but all systems are down. So let's see, all clear, nobody is actually getting electrocuted, it was a false alarm. We could turn the system back on, so immediately goes back to the status that it was before. Thank you for watching the presentation. I hope you enjoyed your time at PepsiCo Canada.